the formula of CAPM. So we said CAPM returns. CAPM returns equals what here, somebody? We must start with risk-free plus what we call the expected return of the market minus risk-free multiplied by beta. Multiplied by beta of what here? Of a security. Multiplied by beta of a security. Multiplied by a beta of a security. So as a quick reminder of what we are doing in our last class, I would want us, ladies and gentlemen, in this case here, to look at some small example, here, where they have given us a risk-free rate as 10%, and then they have given us, ladies and gentlemen, what we call the market, market returns, market premium. They've given us market premium of 5%, market premium of 5%, and then we have a beta of a security as 0.8. So we are required to do something very simple here. We are required here to compute the CAPM returns. We are required here to compute the CAPM returns of the security. CAPM returns of the security. We are required here to compute the CAPM returns of the security as a quick reminder of what we were doing in our last class. As a quick reminder of what we were doing in our last class. I'm so sure there is somebody here who will not be able to get this simple illustration. I'm so sure that there is somebody who will not be able to get this simple illustration. Remember, this is beta of the security. This is risk-free rate of return. Risk-free rate of return. Risk-free rate of return. Risk-free rate of return. So solution, right? So we know the formula, and this is something that we would want really to have it at the back of our mind throughout. We can't go to an exam without knowing CAPM formula, really. So CAPM returns will be equal to risk-free plus expected returns of the market minus risk-free multiplied by beta of a security, right? The risk-free has already been provided. The risk-free here is 10% plus, you see, here, this example has given us market premium, and having been given market premium, there are students who do not know that the premium means over and above. There are students who do not know that the premium means that these guys have already subtracted for us. What we have in bracket is what we call the premium. Whenever you are given premium, please never subtract again. Whenever you are given the premium, please never ever subtract again. Premium, I'm repeating this, that premium, basically for premium, already they have subtracted for us. For premium, already they have subtracted for us. So the market premium, the whole of this will be the 5%. Come and multiply this with the beta factor, which is what here, somebody 0.8. Subtract here with the beta factor, which is 0.8. So if you handle it this way, you will end up getting, from what I'm being told here, you'll end up getting what here? 14%. You'll end up getting 14%. You'll end up getting 14%. So please ensure that you're able to get this 14% because there is an issue to do with body mass here. There's an issue to do with body mass. You'll get some people saying 10 plus 15, or rather 10 plus 5, 15. No. You see, this 0.8 is only multiplying 5%. That's why I would want everybody to compute this. It'll be 10% plus 5% times 0.8, which will end up giving us exactly what here? 14. So the most important thing is for us to remember that risk premium or the market premium means that already they have subtracted. It means that ERM minus RF equals what here, somebody? Equals 5%. ERM minus RF, equals who? Equals 5%. Equals 5%. Already they have done what here? Subtracted for us. Already they have subtracted for us. So are we together as this example is concerned? As this example is concerned, are we together? Are we together? Are we together as this example is concerned? It's only a Tieno Bernard. Okay. Your camera isn't clear. Okay. Great. Just a minute. I would also want us to remember something here, that most examiners will never give you beta. Most examiners will never give you beta J. This beta J, some examiners, actually most of them, will require you to compute beta J. Is there somebody who can remind us the formula of computing beta J? Anybody who can try remembering this great formula of computing beta J so that we can give them a present? Remember, the ones who keep on talking to me, they have to get something at the end of the day. Beta J equals who? Beta J equals who? Beta J, that reminds me, okay. So beta J, they're telling me it is covariance. I have to relate my security with the market. When they want me to give them beta J, I will come, ladies and gentlemen, and give them the covariance between J and the market all over the standard deviation of the market done what here? Squared. All over the standard deviation of the market squared. Very, very important. Very, very important. This is very important for all of us to appreciate. Very important for all of us to appreciate. Now, ladies and gentlemen, listen and listen to me very well. Listen and listen to me very well in form of an example. In form of an example. So for example, we have two securities. We have a security one whose standard deviation here is, for example, 5%. We have another standard deviation of the market, which could be 7%, like that, right? And then these people have given us the correlation coefficient, between the two securities. The correlation coefficient between the two securities has been given as 0.3, And then these guys will come and give us a risk-free. Risk-free, for example, they may give us risk-free is 6%. And then we have, ladies and gentlemen, we have here the risk premium. We have the risk premium, something small. Risk premium is, for example, 3%. Risk premium is 3%. And then we are required to calculate CAPM returns of J. Calculate CAPM returns of security J. Not many students can get this question correctly. Not many. Why? Because they have given us correlation coefficient instead of giving us covariance. So the question is, could we be having some students who know how to get covariance when we're given correlation coefficient? Is there anybody who knows the relationship? Or is there any student who will be able to give us beta J using this correlation coefficient directly? Let me give you a minute to think through this. They want us to give them CAPM returns of J, 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 CAPM returns of J. I'm so sure there are some students here who are joining us here for the very first time. So they say CAPM returns of J at the back of their mind. The only thing they're hearing, right, is a tongue twister. It's like I'm saying, cantai etai, as cantai etai, why cantai etai, as cantai etai. Don't worry, patient space. Great, I can see what Lillian is telling me there. I can see what Atieno is also mentioning there. Very, very important. You guys are very bright. Two ways. There are students who are telling me that you know what, Mwalimu. We know that there is a formula that connects between correlation coefficient here. R, this is supposed to be R. But when you want to get correlation coefficient, you should come and take the covariance between the two securities all over the multiple of the standard deviation of their standard deviations. So you want to get correlation, please write this in full. This is correlation between J and M. You will take the covariance between the two, and then you divide by their standard deviations multiplied. You divide by their standard deviations multiplied. So the correlation has been provided here as a 0.what here? As a 0.3. As a 0.3. And then we have, ladies and gentlemen, our covariance. The covariance is what we do not know. The covariance is what we do not know. Divide this by the standard deviations. The standard deviations we have here, we have 5%, and then we have what here, somebody 7% like that. 5% and 7%. 5% and 7%. 5% and 7%. 5% and 7%. So then out of these, I should be able to get the covariance. Out of these, I should be able to get the covariance. So in short, ladies and gentlemen, here the covariance, please don't give me the answer, it will look up Z. The covariance here will be 0.3 times 5% times 7%. Don't give me this answer. It will be very, very absurd because of the percentage. It will be very small. I don't want the final answer. So once I have the covariance like that, then I'll come, ladies and gentlemen, here and the peak. The covariance is here. 0.3 times 5%, 0.3 times 5% times 5% times 7% is the covariance. Divide this by the standard deviation of the market what here? Squared. Divide this by the standard deviation of the market squared. You see the standard deviation of the market squared. This is 7%. In this case here, done what here? Squared. 7% squared. And of course, I would have been better off leaving out the percentages. I would be 100% better off leaving out the percentages. I'll still get the same answers. So now using your calculator, could you kindly come and mention this as 0.3 times 0.05 times 0.07 divided by 0.07 squared. 0.07 squared. And then you give me an answer. 0.07 squared. 0.07 squared. Right? I would want to see who will be the first one to get this correctly. Will be the first one to get this correctly. Will be the first one to bail the cat. Will be the first one to bail the cat. Will be the first one to bail the cat. What do we have there? What do we have here? What do we have here? So most of them are giving me 0.2143, 0.2143, 0.2143. So this is 0.2143. 0.2143. Now, ladies and gentlemen, this is method number one, and it's a bad method indeed. If I'm the one doing this in an exam, and this one I have to capture it down as a note, that we've got two distinct formulas of getting beta J. The first method is the covariance approach. The first method is the covariance approach, and the covariance approach, our beta J, will always be obtained by taking covariance between J and M divided by the standard deviation of the market done what here? Squared. Covariance approach. Covariance approach. Covariance approach. Very important for me to capture this, the covariance approach. And then number two, in this case here we have the correlation approach. The correlation approach. So the correlation approach, my beta J will be equal to correlation between J and M. Correlation between J and M multiplied by the standard deviation of J. The standard deviation of J of the security all over the standard deviation of the market. All over the standard deviation of the market. So anytime they want me to give them beta J, I'll always take, in this case here, if the examiner has given me the correlation, I'll take the correlation between J and M. I multiply this with the standard deviation of the security given divided by the standard deviation of the market. So like the question that we're doing here, if I'm using the second approach, If I'm using the second approach, the correlation that was given to me is 0.3 times the standard deviation of J. Can somebody in this case here remind us the standard deviation of J that was given? J is any security times the standard deviation of J, which is 5%. If I wish, I can leave out the percentages. So times 5% all over the standard deviation of the market, which is what here, somebody? 7%, isn't it? 7%. If I wish, I can leave out the percentages because at the end of the day, they cancel out, giving me what figure, somebody here? 0 point, giving me what figure at the end of the day? Will be the same. Will be the same. 0.2143. So 0.2143. 0.2143. So vis-a-vis the market, this security, how is its risk? How is the risk of this security vis-a-vis the market portfolio? Is it a high risk or a low risk? This security J. High risk or low risk? Could you kindly talk to me? Is it a high risk or low risk? It's low risk, ladies and gentlemen, simply because you can bear witness with me that this one, remember the beta of this market, the beta of the market is exactly 1. The beta of the market is 1. Anytime you have a risk anytime you have a security whose risk is less than 1, remember beta is a measure of risk, whose beta is less than 1, then that automatically tells you that that particular security is a low risk. So basically we are saying there, although this is just trying to demonstrate broad and deep understanding of the subject, otherwise really we will not have even mentioned this anywhere. But you see, I would want to show my examiner that I know this subject, I know the subject matter so seriously, and therefore you should give me a pass. You should give me a pass. So you're saying that J is a low risk, security, which in this case here can only be bought by defensive, investors, which can only be bought by defensive investors or risk-averse investors or risk-averse investors. Don't forget, this should not make us to detour. At the end of the day, what this examiner wanted us to do, ladies and gentlemen, is to calculate CAPM returns of J. So is there somebody who will be able to give us the CAPM returns of J? Is there somebody who will be able to give us the CAPM returns of J? Let me see. Is there anybody who will be able to give us the CAPM returns of J? Let me give you 1 minute. CAPM returns of J. Oh, I love CAPM. When they mention CAPM returns, if I'm the one who is doing this, I will remember straight away the formula of CAPM. CAPM returns equals who? I forgot to tell you to highlight this. This is a very important section of my syllabus. Very important section. So nowadays we don't recommend the color that students should use. You decide the color you want to use. If it's yellow, use yellow. If it's blue, use blue, because now you guys decided to bring politics into this, and I don't talk about politics at all, really. If these politicians were to help me like now, they were shouting horse here, I will not be here tonight, right? Right? So CAPM returns of the security equals risk-free plus ERM minus risk-free into beta of a security. So risk-free, I've grabbed my question, unfortunately. What was the risk-free rate of return? What was the risk-free rate of return? Somebody remind me. Risk-free rate of return is 6%. You cannot decide to omit the percentages. How about expected returns of the market? Have they given me market returns or the premium? What have they given me? What they have given me, is it premium or return? So if it's premium, no subtraction at all. If it's premium, no subtraction at all, it's 3% premium. If it's premium, already premium means over and above. Already premium, they have subtracted for me to get the premium. So multiplied by the beta factor, which is 2143. Which is 2143. So you guys, are you able to get really this thing? Are you able to get this thing correctly? So they're telling me it is 6.64%. It is 6.64%. Thank you very much. We shall overcome. We shall overcome. We shall overcome. So then, ladies and gentlemen, I would want us to go a step further and mention their title: arbitrage, pricing, pricing model. As mentioned there, arbitrage, pricing model. So arbitrage pricing model, this is a serious model that exercises what here? Polygamy. Polygamy. It is a multivariate model. So tell us there that APM is a multivariate model. Is a multivariate model. Just in this case here, for our understanding, it's important to note there that CAPM is what here is a univariate. A univariate model that assumes a security returns are influenced by the market premium, only. The market premium is the only one in this case that will be fluctuating, and as this fluctuates, automatically we shall be having our CAPM returns changing. So CAPM is a univariate model. Uni means what here? One variable. So CAPM is a univariate model that assumes a security returns are influenced by the market what here? Premium only. By the market premium only. Whereas APM is a multivariate model. Yes, Asezi is asking whether univariate means single factor model. Yes, it's a single factor model. Thank you very much. Uni means one factor or single factor model. So as Asezi is telling us, CAPM basically is a single factor what here? Model. It's a single factor model. Now today I'm here to teach you how to calculate arbitrage returns. How do we get arbitrage returns? So, ladies and gentlemen, for us to be able to get arbitrage pricing model returns without a C, what we shall be doing, we shall be taking the risk-free rate plus into bracket here we have expected return of the security, given factor 1, because now there are many factors affecting the APM returns. So it will be expected returns of a security given factor 1 minus risk-free. Multiply outside here with beta of factor 1, plus, ladies and gentlemen, into brackets here, expected returns of the same security given factor 2 minus risk-free multiplied by beta 2 plus blah, 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 up to the end of our thinking capacity. You know, those factors really could be very many. They could really be very many. So the most important thing is for us to appreciate, ladies and gentlemen, that if it's APM arbitrage pricing model, it's a multi-factor model. We shall be assuming that this particular security S return or price has got what here is a function of many factors. So please, just for your revision, you could mention this in full, that this is expected returns of a security given factor 1. Expected returns of a security given factor 1. Expected returns of a security given factor 1. Given factor 1. For this factor 2, the others, you'll be able to appreciate. You'll be able to appreciate. Now, ladies and gentlemen, here we have an exercise. Here we have an exercise. So we have here factors. So factors, we have A, B, C, right? We have what we call sensitivity. Sensitivity factor. Sensitivity factor. This could be 0.3. This could be -2. This could be 5. 5, like that. All right. All right. All right. And then we have here expected returns, expected premiums, expected premiums, expected premiums. We could be talking about 5% here, 7% there, and then we have 10% here, like that. Right? Right? Mm-hmm. Tell us there that A is a size factor. A is a size factor. B is a foreign currency. A foreign currency factor. A foreign currency factor. B is a foreign currency factor. And then C is a market premium. Is a market premium. A market premium factor. Is a market premium factor. And then they are giving us risk-free rate of return. My pen is not very nice today, you'll forgive me, but I hope you guys are able to follow what I'm writing here. My risk-free rate of return, is 11%, is 11%. Risk-free rate of return is 11%. And then we are required here to do something very simple. We are required here, number 1, to get APM returns. Number 1, to get APM returns. And then number 2, to get the CAPM returns. So number 1, we get APM returns. And then number 2, we get the CAPM returns. APM returns. And then number 2, we have the CAPM returns. We have the CAPM returns. We have the CAPM returns. Great. I've been suffering here for nothing. This is now the best shot. Great. Great. Yes. Great. Now I'm very happy now. Yes. Sawa kabisa. You want to tell me you've been suffering in silence? You've been suffering in silence, eh? Great. Now that this thing is quite visible, could you kindly prove to me that you have been suffering? That is why you have not been understood. Could you now kindly give me the APM returns correctly? APM returns correctly. Please give me the APM returns correctly. Please give me give me the APM returns correctly. Give me the APM returns correctly. So pata potea, APM returns, what do we have here? What I know for sure, that's factor sensitivity. Factor sensitivity, this is equivalent of beta. Anytime they talk of sensitivity factor, that is beta. Sensitivity factor is beta. Sensitivity factor is beta. Sensitivity factor is beta. So if I could be of help to you guys, I will come here and calculate. I will come here and calculate. I will come here and calculate the APM returns. So I'll come here and calculate the APM returns. Unfortunately, I have already the formula written down for me. So my work is very easy. My work is to come and plug in. So the risk-free has been given to me as 11%. Plus, I know, ladies and gentlemen, here, for the first factor, already they have given me the premium. The first factor's premium is given. So the first premium there is 5%. Multiply this by the first factor's beta, which is 0.3, plus the second factor's premium. The second factor's premium is 7%. 7% multiplied by the second factor's beta, which is -2, plus the third factor's premium, which is 10%, 10% multiplied by beta of the last factor, which is 5, of which I'm able to see some students giving me some great answer there. Some great answer there. Who are these students who are able to give me an answer? Who are these students who are able to give me an answer regarding APM returns? So APM returns, according to Mary Njoki, it should be minus 1.5. I cannot take that figure. That figure cannot be correct. Please check your body mass nicely. As you're punching, just ignore the percentages here. So you say 11 plus 5 times 0.3 plus 7 times -2 plus 10 times 5 plus 10 times 5. Aha, I can see others giving me 11 point something. I can see 66. I can see 66. So which formula have I used? I've used APM, arbitrage pricing, the one of many factors. The one of many factors. You can see they're getting 70.5. Can it really go to 70%? And yet I'm seeing this will be like 1.5. Here, actually, I'm subtracting something. And this is just 0.5%. How does it get to 70? How does it even become 40? 48. Seems 48 is correct. 48.5. Ebu fanya moja moja. Fanya moja moja na body mass. Fanya moja moja na body mass. Could you kindly start with this 5%? Just take 5. 5 times 0.3 ni ngapi? 5 times 0.3 ni ngapi? Plus 7 times -2. -2 plus, in this case here, 10 times 5. Or put those decimals if you wish. Put those decimals if you wish. If they're the ones which are confusing us, put them there. You talk of 0.11 plus 0.05 times 0.3 plus 0.07 times -2 plus 0.1 times 5. So most of them are getting 48 point what here. Most of them now are in agreement that 48.5 is a correct answer. 48.5%. 48.5%. It's confusing working without a percent, without decimals. Without decimals, it'll give you the correct, whichever way. Whichever way. It's not confusing. It's body mass. It's body mass that students are not very good with. Body mass that students are not very good with. I'm not getting. Just try. You can start with this. Put the decimals. Say 0.05 times 0.3 plus 0.07 times -2 plus this 0.1 times 5. Whatever you get there equals, come and add it to 0.11. 0.11. Take your time, Susan. Take your time. Take your time. Please take your time. Please take your time. So all of us, are we able to get that 48.5? All of us? All of us, are we able to get that 48.5? 48.5. All of us now are getting the 48.5. All of us are getting the 48.5. Great. Now, could we kindly, ladies and gentlemen, go to the next level and get now the CAPM returns ourselves? Let's try getting the CAPM returns ourselves. Shall we be able to get the CAPM returns ourselves? Shall we be able to get the CAPM returns ourselves? CAPM returns. Susan has already gotten the figure. Thank you very much, Susan, for the feedback. Thank you very much, Susan, for the feedback. Great. So now when it comes to CAPM returns, ladies and gentlemen, I just need to write the formula down first. So we write down the formula. So we know, ladies and gentlemen, that our CAPM returns, will be equal to who? We know the formula, this is risk-free plus ERM minus risk-free multiplied by who? By beta of a security, like that. And then I will remember that the CAPM returns only works with one factor alone. CAPM works with the market premium. The market premium factor. It disregards all the other factors, whichever fancy names they may decide to use. In the other factors, like A is a size factor, I'm told B is a risk, foreign exchange risk factor, whatever. What I'll use here, it is C, which has got an association with market premium factor. And therefore, so here it is only C that is relevant. And therefore, my CAPM returns of a security will be equal to, could you kindly give me the risk-free? The risk-free, we got this as 11%, plus the market premium. The market premium factor is 10%. So 10% times what here? The beta factor, which is 5. Beta factor, which is 5. So Atieno is giving me a figure of what here? 61%. 61%. Thank you very much. 61% or 0.61. 0.61. Thank you so much. Now, could we kindly look at, from our past papers, could we kindly look at November 2019, question number 3, boy. November 2019, question number 3, boy. Remember CAPM from the definition. CAPM makes use of a market premium factor. And we have 3 factors. Remember, we had A. If you remember, we had the definitions here. We said A is the size factor. B was foreign exchange factor. And the C was what here? Market premium factor. So CAPM cannot make use of any size factor, cannot make use of any premium factor. It can only use what here? The market premium factor. The market premium factor. I hope at least that helps you, however small. That's what we brought here, market premium factor for CAPM. Great. So we are talking over November 2019, question number 3, boy, Job Ochieng. Are we there? Please put your thumbs up very fast, the way you used to this. Put up your thumbs very fast if you're getting this. Put up your thumbs very fast. Or you simply write Y for yes. Great. Felicitas Kithome. Godon Were. Great. If you have the paper, I'm so sure there must be somebody who is stranded. You could also kindly just send it to our WhatsApp. So you're told Job Ochieng, an investor, believes that there are 3 important factors that determine the expected return for a particular common stock. Job uses the following factor betas and the factor risk premiums. The risk-free rate is 5%. So you're required there to provide the expected return for the stock using the arbitrage pricing theory or arbitrage pricing model, doesn't matter really, APM model. Explain 2 differences between CAPM and APM model. So could you kindly, in this case here, try part 1 for me, and everybody must get this right. If you don't get this right, I will send some punishment your way, and they say that tonight you should not be given dinner tonight by anybody. No dinner tonight. No dinner tonight for you. No dinner tonight for you. No dinner. November 2019, question number 3. I'll just tell your spouses there, and I know they're listening to me. Some of them are listening to me. If you don't get this correctly, dinner for you, kaput onge, right? All right, November 2019, question number 3, boy Jobochie. Oh, this one of Job Ocheng is from which sitting? It's C, eh? It is C. I'm being told it's C. It is C, Job Ocheng. Please correction there. It is C, Job Ocheng. It's C. Thank you, Leah. Thank you so much. Macharia, go to C. Same question, part C. Same question, Macharia. Same question, part C, Job Ocheng. Thank you. So Claire gets 12.15. 12.15. Got on 12.15. Don't I need to pinch these students? These are bright students. Pinch them slightly so that they don't forget this formula. Keeps, thank you. 12.15. 12.15 is correct. 12.15 is correct. 12.15 is correct. Great. Felicitas Nduku, 12.15. Sharon Yegon, 12.15. 12.1. Is there anybody who is not able to get this correctly? Anybody who is not able to get this figure correctly? Susan, put in your hands in this. So long as you appreciate the formula, Susan, you'll be able to get this. You should be able to get it, I'm telling you. Not unless I say you're not going to get dinner tonight. Those of you who are staying with their parents, I'll just tell your parents, this lady, this gentleman should not be given food tonight. Let them fast. They will be getting my answers. They will be getting answers to my questions. Adelaide, great, 12.15. 12.15. Michelle, great, 12.15. And that reminds me that there are 3 ladies that we took their numbers here, and I never remembered to send them anything. I'm a bad man. I'll remember tonight. I hope I get that photo. There are some 3 ladies we never gave something. Yes. Macharia got the answer. Susan, I'm waiting for you, by the way. Susan, na usidanganya kwa hujapata. I'm waiting, Susan, uweke hapo dancing emoji. Dancing emoji kama umepata correct sasa. There's a dancing emoji there. And this class is very aggressive. You can see straight away the messages. There are 217, you can imagine. 217. Great. Thank you. So Susan amesema hajaelewa tumuonyeshe. Maybe Susan amekuja late kwa class, because really this is a straightforward thing. It's a straightforward thing. You cannot fail to get this. So long as you kuja class in good time, you cannot fail to get this. This is the simplest thing ever. Any examiner who gives you a question on this area is an examiner who is wishing you what year success. So when they mention APM or APT, arbitrage pricing model returns, I'll straight away remember that this is a multi-factor model of getting returns. So how does it work like? We start with risk-free plus expected returns of the security given factor 1 minus risk-free multiplied by beta 1 outside there. Plus we have the expected return of the security given factor 2 minus risk-free multiplied by beta 2 plus these things here could be very many all the way up to the end of what year? Thinking capacity. Great. I can see Mercy is dancing there. Great. Now, so as the examiner given me the risk-free rate of return, oh yes, 5%, right? Remember that these are normally called what here? Premiums. Premium means what here? They have subtracted for you. So like for factor 1, I can see the factor risk premium. It is 2.5%. 2.5%. Right? That's the first premium given there, multiplied by beta of factor 1, which is 0.7. Right? Like that. Plus now go to factor 2. So factor 2, I'm interested in its premium, which is 5%, and its beta, which is 1.2. Plus the third one, I'm picking the third premium, 6% times 0.1. And I want to believe that this is what they did to get that 12.15%. So I hope Susan, and of course, any other student who may not have gotten this correctly, this helps. And pick your calculator, please. Pick your calculator, please, and punch. Pick your calculator, please, and punch. It's a straightforward thing. It's a straightforward thing. It's a straightforward thing. Pick your calculator and punch these. Thank you so much. Thank you so much. Great. And then number 2, they asked us to explain any subtle differences between CAPM and the APT model. So we have here CAPM and APT or APM. Is there anybody who is able to give us differences really very fast? I know that CAPM is single factor or univariate. Single factor model. This is multiple factor model. Thank you. Go to the second one. Is there anybody who can? I remember always simple ones. So we have here CAPM, ladies and gentlemen, is single period model. This one here is multiple period model. Now all the others should be able to come from you. All the other points should be able to come from you. So remember, CAPM is 5% per annum, but APT can be even for returns of 3-4 years can be given. So multiple period model. So I'm waiting to get the others, ladies and gentlemen, from you. So CAPM uses market premium only. APT has got other factors here. CAPM is single factor model, which is the market premium. Other factors, this can make use of any. Thank you for that. So CAPM assumes normal distribution, but APM, so in this case here, this one here assumes normality. This one here assumes normality, whereas APT, ladies and gentlemen, we can use any probability distribution model, can make use of any probability distribution model, even if they are skewed. Remember, CAPM, ladies and gentlemen, is the one which uses this special ugali ya Mluya. Unajua kuna kabila moja tu anajua kupika ugali Kenya mzima. Kabila tu moja tu zapika ugali ambayo iko balance. Sawa, wengine sisi wote hatuwezi ugali ambayo iko balance, tena ugali tamu unaweza takula bila mboga, ni Mluya. Hao wengine ni wa APT. Yaani anapika ugali either ikuwe kama supu, ugali ambayo iko skewed. Ugali ambayo iko skewed hivi. So it can use any probability distribution like that. Mwalimu acha kuongea mbaya. Sawa. Pika ugali tuletee hapa studio tuone. Pika ugali tuletee hapa studio tuone. Sawa. Aya. So CAPM recognizes the existence of market portfolio. Thank you very much. So ladies and gentlemen, CAPM cannot work without a market portfolio. CAPM cannot work without a market portfolio. A market portfolio is that most attractive portfolio in the market. APT can work without the market portfolio. So can only work with market portfolio, works with market portfolio. So the market portfolio must, as this lady is telling us, the market portfolio, you can see ERM minus RF. So the market portfolio must be there. In this case here, APT can work without market portfolio. APT can work without the market portfolio. Can work without market, like now here, there is none. None. Can work without market portfolio, can work without market portfolio. So this is what we were required, ladies and gentlemen, to do. This is what we were required to do. This is what we were required to do, like that. Now, during our break time, I would want you guys to bring me a question that was brought some time back here. Of course, there are very many differences. But you see me, I'm exam-oriented. Nowadays, you can't get somebody asking you for many factors, many differences. Nowadays, it is 2, 3. Why should I give you 10 differences? And I mean, actually, for me, if you remember this, that CAPM is very faithful. CAPM is single. APT or APM, hiyo ni ya gani? Hiyo ni ya polygamy, multiple. Hata hizi mbili peke yake zinatosha. You pass, you go. You'll go to do more research when you're doing your PhD in finance, right? Now, so during our break, ladies and gentlemen, I would want somebody to look for some past paper that I'm trying to look for here that I'm not able to get. Ambao walikuwa wametuuliza Pastor Stamberg's model, Pastor's model, ama Pharma French model. Kuna question walikuwa wametuletea ikashinda wanafunzi sana. Pastor Stamberg's model imeuliza namna hiyo ya portfolio. Kuna question paper fulani hapo inauliza Pharma French model. Hebu itafute past paper during our break time. Ukipata nitakwambia kitu mzuri. Thank you very much. So we take a break over how many minutes? 3 minutes. 3 minutes. In those 3 minutes, somebody should have gotten those papers for me. Great. So we are told there, ladies and gentlemen, this is November 2020, question number 2, boy. Question number 2, boy. Are you able to see that question yourselves? Are you able to see that question yourselves? Are you able to see that question yourselves? Yes. So we are told there, the estimated factor sensitivities of Diamond Limited. The estimated factor sensitivity of Diamond Limited to Pharma French factors and the Pastor Stamberg's model and the risk premium associated with those factors are given below. So required, they want us to give them the required rate using the Pharma French. This Pharma French doesn't have an R in between. Doesn't have an R in between. So after APM or APT model, ladies and gentlemen, I would want us to look at Pharma. So you know it's CAPM, it's portfolio. We have a CAPM, APM. Now another one is called what here somebody? Pharma French model. Pharma French model. So under Pharma French model, what we have, ladies and gentlemen. So under Pharma French model, what we have here, we're supposed to know that this is a multi-factor model or variate model, multi-factor model that specifically uses the following factors. To determine the required rate of what year? Rate of return. To determine the required rate of return. What year? Rate of return. All right. So it uses number one, it uses the market factor. Number one is the market factor. Number two, it uses the size factor. And then number three, lastly, it uses the value factor. So basically we are saying here that the French returns of a security, the French returns of a security will be equal to the risk-free rate of return, plus we have here the market premium. Market premium times, in this case here, beta 1, plus we have the size premium. The size premium times beta 2, plus we have here the value premium, times beta 3, the value premium times beta 3. So French returns, required returns of a security will always be defined by 3 factors. We have the market factor, size factor, and then we have value factor. Then we have value factor. So then could you kindly go ahead and give us, these parameters? Could you kindly go ahead and give us these parameters? What do we have? Right. So from the question given here, ladies and gentlemen, what do we have? Oops. Sound must have been very low. All right. So risk-free, Ningapi risk-free. Risk-free, you can see there is 5%. So risk-free is 5%. The market premium, are you able to see the market premium? The first factor there is called market. So I'll pick the market premium there, which is 5. If I wish, I can even leave the percentage in there. Percentage, because that is in form of percentages. So we have 5% for the market premium times its factor sensitivity. Factor sensitivity is 1.05 plus the size premium. The size premium, I can see it is 2.5. The size premium is 2.5 times its risk factor, which is 0.65, plus, ladies and gentlemen, the value premium is 4.5. 4.5 times what here? 4.5 times minus 0.2 times minus 0.2. So could you kindly give me an answer there? If you wish, you can put the percentages if you want. Ensure that your body mass is okay. Ensure that your body mass is okay. So 7.725, like that, 7.725. Are we able to get these French required returns at 7.725? Yeah. So I hope everybody is able to get this. Thank you so much. They are confirming there in big numbers. 7.725, correct. And then now we go to the pastors. What here? We go to the pastors model. Let's go to the pastors model. That's from a French. So we go to the pastors model. So pastors model. So Pharma French does not have liquidity amongst its factors. No. Liquidity is an extension of what here? The pastors model. So liquidity is an extension of the pastors model. So we have here liquidity. Not liquidity, but we have here the pastors model, Pastor Stamberg. So Pastor Stamberg model, Pastor Stamberg's model. So it uses 4 factors. So it uses 4 factors. These 4 factors are which ones here? The 4 factors are which ones here? The 4 factors are market factor. We have here market factor. We have size factor. We have value factor. And then, of course, we have liquidity factor. factor, liquidity factor, liquidity factor. So basically, to get pastors returns, the pastors returns of a security, what I'll do, I'll come and pick the risk-free rate of return plus the market factor, market premium. The market premium, right, multiplied by first beta plus the size premium, multiply this with beta 2 plus the value premium, multiply this by beta 3 plus, in this case here, the liquidity premium times what here, somebody beta 4 times 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 beta 4. Sasa unakuja hapa straight away, unaangalia risk free sasa pale ni gani? Risk free ni sawa na treasury bill rate. Risk free is the same as the treasury bill rate, which is 5. You can ignore the percentages, plus the market premium. Market premium is 5 times its sensitivity factor, which is 1.05, plus we have in this case here the second factor's premium is 2.5 times minus 0.6 plus 4.5 times minus 0.2 plus 4.5 times what here, somebody, times 0.2. So if you do it that way, then you'll be able to give us the correct answer. You'll be able to give us the correct answer, which is 8.825. 8.825%. That is the pastor's what here? Returns. That is the pastor's returns. Pastor Stamberg model. 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 They're saying it's 6, not 8. So it's supposed to be 6 point what? Check again. Give me the correct answer. Give me the correct answer. Give me the correct answer. Give me the correct answers. 8.625. 8.625. 8.625. 8.625. 8.625. Thank you very much. 8.625. 8.625. 8.625. 8.625. Thank you so much. Thank you so much. Thank you so much. Thank you, and thank you so much. Great. And now that brings me to the end of my today's class. So with this homework, you guys should be sorted out. November 2018 question 4B. November 2018 question number 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 4B. I would want you guys to try that one. Yes. And November 2019 question number 3. November 2019 question 3A. Duncan Kipchumba. November 2019 question number 3A. And then we have November 2018 question, no, not 18. November 2018 question number 4 boy. So are we together there? 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 Great.